So this is a common error that is often made with vanishing edge pools. And what happens is that vanishing edge pools, most common defects that I see in construction defects is the basin is undersized, the water level in the basin is too high, the autofill system is the wrong unit, wrong model, meaning it's not for a vanishing edge pool. And the overflow line competes with the autofill of the basin to create tremendous water losses. And tremendous water losses, water imbalance, hydraulic imbalance is just all related to a number of components. And it's a repeated system in the industry that when I'm contacted by homeowners, attorneys, or pool builders across the United States, that when I inspect these projects, I see the same errors, just in a different situation. This is what's called a float in a cistern. So it's a cistern which is very comparable to what you have in a toilet tank. What happens is that it's in its own contained canister, but it's connected to the basin. And what it does is it refills the basin. The problem is I identify when I measure it, in this case, we see it's up very high to the decking, that it's too high and that it will just be refilling that basin to a very high level. What does that mean to the owner or owners of a vanishing edge pool? It means that it will be overfilling the basin and then it will be escaping out of the overflow line. So let me explain what that means. So we see that this just continues to run. It will never fill up the canister because that water is going into the basin and then it's escaping from the basin via a overflow line. So the overflow line is up fairly high. So let's take a look at where that overflow line is. The overflow line is here somewhere. The water level is up very high. The autofill is constantly running. Now, a little more investigation tells me that the autofill is running so much because that water is escaping via the overflow and the autofill system cannot recognize to shut itself off, so it continues to run. Again, this is a system defect. In other words, there are a number of contributing factors that cause this defect to happen. The overflow line is very similar to the overflow you have in either a bathroom basin, a bathroom vanity set up with a basin, and a bathtub. It's a small opening, generally in an inconspicuous area where water will flow when the level gets too high. Now, we haven't even considered at this point, when I'm looking, what happens when, say, 100 bathers get into this commercial style pool and displace 1,500 gallons. What does that mean to the basin? It probably means that the basin should have been about 15 inches to 20 inches deeper so that it has some capacity to hold that surge. There is no capacity. So what happens is the water flows over the edge from the bathers, it goes out the overflow, and then when the bathers leave, then the water from the basin refills the pool level that was lost, which could be an inch or 2 inches. And then the autofill system kicks on again. So there's that repeated vicious cycle of never maintaining the right equilibrium because the overflow line is being used by the autofill and the basin is not sized properly and the water level in the basin is at the wrong elevation and the autofill system is at the wrong elevation, and it's typically the wrong unit. So let's take a look at a project where the overflow and the autofill were separated. And this is an vanishing edge pool on Lake Conroe. So we see the water level is lower in the basin. But let's take a look at where is that overflow line in relationship to the fill line, the float level. Now, this is looking into the basin during construction. And let me show you where that line is. Go back to there. Put that on pause for a moment. I'll let it go up. Now it's on pause. That's the autofill line. That's where the float mechanism would go. And the overflow line, we can't see it, but let me show you where the two would be. So the float level is here. The water level for the basin would be at the lower level. That's where it would hold. That's where it should hold, down at the lower level. A completely different autofill system, not at the deck level, not at the patio level, pool patio level around the pool. The overflow line is concealed, but it's up here. And so you can see that it takes more distance for the water level to rise before it comes into conflict with the overflow. And that is the correct layout, the correct system. Now let's take a look at another system, which is at another swimming pool. And it's, again, this is a common situation that occurs repeatedly with these vanishing edge pools because they're just not intuitive to build, and they do require some knowledge to build. So in looking at the setup, there's the autofill system. Let's go back to that. I'll show you the overflow system in a moment. We'll come back to this image and take a look at the overflow system. But the autofill is right here. So that's the autofill. We're going to see the same situation that we saw in the other pool. So autofill, float mechanism, it's going to start, it's about this elevation. So water level will be somewhere there on the tile line. So it's up high. Again, we don't have enough surge capacity, so that's going to represent a problem. But then let's look at the overflow line, because the overflow line will tell us something as well. And the overflow line is let's go and take a look. Right there. There it is there. Now, how does that operate? Let's take a look. We're using a different example, but it's the same situation. So water level will be somewhere around here, and overflow is 2 inches down. I'm just going to draw that here just to show you. So the water level maybe has a couple of inches before it just starts flowing out. So as soon as bathers enter this pool and the water level rises, it goes out of the overflow, which goes down to the lake in this situation. The bathers drop down 1 inch or 2 from the pool, goes into the tank or the basin, goes out. They get out of the pool, and here we go, refill again unnecessarily. So again, what tells me in this particular model, for example, is it tells me if the water level had been down there, it meant that the autofill system would not be visible up here at deck level on the other side. So now let's look at another model, and we're going to look at a cross-section now of another model. And the cross-section will tell us in a 2D what should happen in 2D. So this now explains to us what we saw visually with those examples. So the water level should be down at the lower level, which is here, down there. The autofill system should be low, which is down here, and not up the top. Okay, hang on now. You seem to be competing here. And we have the overflow is actually up here. And then the water level can rise before it gets anywhere near the overflow. Now, what that does is it gives us surge capacity. It gives us room for rain. If we get rain in the pool, it'll flow over into this area, which is not only surge capacity for bathers, but there's a calculation made for rainwater, for water that's in the pipes that ends up, when the pump's off, ends up into the basin. So main factors are that I continuously see is the basin is too small. The overflow competes with the automatic water leveling device and produces very, very high water bills in the month. And also that the autofill is the wrong one, typically, and also set at deck level, which is an error when it comes to vanishing edge pulls. So I've now covered pretty much the major defect that I see repeated and many times, many defects that I've observed when I inspect vanishing edge pulls. When I write reports for vanishing edge pulls, they're going to include the same defect repeatedly. And when I'm contacted by pool builders before they build and ask me to assist them to build, it's the first detail that I cover. And I also cover the hydraulics and the basin size and the relationship between these components. When you consider them, they're very, very simple. Unfortunately, in construction defect, they're repeated over and over again, and they cause a lot of problems for hydraulic balance.